बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि व आलिहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि व आलिहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन। Momentum. This question is from November 21, paper 41, and the question number is 2. Two small smooth spheres A and B of equal radii and of masses km and mkg respectively. So this is sphere A and this is sphere B with masses km kg and mkg, and it's given k is greater than 1. This means mass of A is greater than the mass of B. Are free to move on a smooth horizontal plane. Well, A is moving towards B with speed 6. So the speed of A is 6. And B is moving towards A with speed 2. So the speed or velocity of B is 2. After the collision, A and B coalesce and move with speed 4 meters per second. So this is the situation after the collision. A and B coalesce and their combined mass would be 6 plus 2, km plus m, which is k plus 1 times m. And their combined speed would be v, and it's given 4 meters per second. This is here. Now we need the value of k. So according to law of conservation of momentum, total initial momentum km times 6 plus 2m will be total final momentum, which is k plus 1 times m times 4. So by solving this equation, we can get the value of k. So k is 3. Find in terms of m the loss of kinetic energy due to the collision. So loss in kinetic energy. This is the kinetic energy before the collision, or initial kinetic energy, minus kinetic energy after the collision. So kinetic energy before the collision means kinetic energy of A and B. Because both particles were moving before the collision. So kinetic energy of A before the collision is half km into its speed, which is 6. Kinetic energy of B before the collision is half m times its speed, which is minus 2. Speed is 2 and velocity is minus 2. So you can just write 2 here or 2 square here. Kinetic energy after the collision. So that is half km plus m into 4 square. And the value of k is 3. So by substituting k3, we can have loss in kinetic energy in terms of m, which is 24 m joules. And this is the final answer. The next question, and this question is from specimen 20 paper 4, and the question number is 3. Three small smooth spheres A, B and C of equal radii and of masses 4, 2 and 3 respectively. This is the mass of sphere A, this is the mass of sphere B and this is the mass of sphere C. Lie in that order in a straight line on a smooth horizontal plane. Initially B and C are at rest, so this is important. And A is moving towards B with speed 6. So this is the condition before the momentum. A is moving towards B with speed 6. It's here. And B is at rest. And the mass of A is 4 kg and the mass of B is 2 kg. After the collision with B, sphere A continues to move in the same direction. Same direction means in this direction, but with speed 2 meters per second. Now this is the sketch after the momentum, after the collision, sorry. So A, B, and the speed of A is 2 and the speed of B is V, and we need speed of B after the collision. So that is very simple. We can do this by using law of conservation of momentum, and according to law of conservation of momentum, total initial momentum is equal to total final momentum. This is momentum of A and this is momentum of B. Hence V is 8 meters per second. And the speed is 8. Now sphere B collides with C. So this is here. This is sphere A. After the collision, the speed of A was 2 and the speed of B was 8 and C was at rest. And the mass of A is 4, mass of B is 2 and the mass of C is 3 kg. Sphere B collides with C. In this collision, these two spheres coalesce to form an object D. So this is the sketch after the collision of B with C, and this object is known as D. So the final velocity of this object after the collision would be V, and the mass, combined mass, would be 5 kg. And the question is find the speed of D. So this is very simple. So total momentum before the collision. So 8 into 2, this is the momentum of particle B. Momentum of C is 0 and momentum of D is 5 into V. Hence V is 3.2 meters per second. The last part of this question, show that the total loss of kinetic energy in this system due to the two collisions is 38.4 joules. So this is very simple. By using loss in kinetic energy formula, we can do this. Kinetic energy initial minus kinetic energy final. Means kinetic energy before the collision and kinetic energy after the collision. Kinetic energy before the collision. So before the collision only particle A was moving. So half mass of A is 4 and its speed before the collision was 6. Kinetic energy after the collision. A was moving with speed 2 and this is D. So half mass of A 4 and its speed after the collision was 2. And D half into mass, combined mass was 5 and speed is 3.2. Well, when you will simplify this, you'll get 38.4 joules. And this is what we had to show. The next question. This question is from November 20, paper 43, and the question number is 4. I'm sorry. Two small smooth spheres, A and B, of equal radii of masses 4 kg and m kg respectively, lie on a smooth horizontal plane. So this is sphere A. I'm sorry. And this is sphere B. And their masses are 4 kg and m kg respectively. Lie on a smooth horizontal plane. Initially sphere B is at rest and A is moving towards B with speed 6. So this is the speed of A and B is at rest. After the collision, A moves with speed 1.5 and B moves with speed 3 meter per second. It's not mentioned in which direction A would move. So there are two possibilities, this or this. So after the collision, this is A and this is B. And B moves with speed 3 meter per second. This is obvious. B will move in this direction. But we don't know the direction of A. It could be this or this. So there are two possibilities. And the question is, find the two possible values of the loss of kinetic energy due to the collision. Two possible values means because of these two directions. So first we will find loss in kinetic energy with this direction of A and then with this direction of A. Number one, we have to work for this direction, 1.5. So when A was moving in this direction, sorry, after the collision, so the value of m would be, according to law of conservation of momentum, 4 into 6 plus 0, 4 into minus 1.5 plus 3 into m. So the value of m is 10. Now when A was moving in this direction after the collision, so 4 into 6 plus 0, 4 into 1.5, 3m. Then the mass of B would be 6. I'm sorry. Now we have to find the two possible values of loss in kinetic energy. So when mass of B is 10, then the loss in KE initial minus KE final. So KE initial means kinetic energy of A, because only A was moving before the collision. So kinetic energy of A would be half into 4, and its speed before the collision was 6. Now this means kinetic energy of both, because both were moving after the collision. I'm sorry. Half into mass and its speed after the collision or velocity is minus 1.5 square. And B, half into its mass, which is 10, and speed 3. So this is 22.5 joules. Now second possibility, when the mass of B is 6 and A was moving in this direction. So loss in kinetic energy. So kinetic energy initial, which is half into 4 into 6 square, minus kinetic energy of A, which is half into 4 into 1.5 square, kinetic energy of B, which is half into 3 into its mass. Basically half into 6 square into 3 square, half into 6 mass into its velocity 3. This is 6. Now this value is 40.5 joules. So because of these two directions, we got two values of m, and then we found loss in kinetic energy with these two values of m. Well, I will discuss the leftover questions in my next lecture, inshallah. Allah Hafiz.